Okay, perfect. This is being recorded now. So thanks for everybody joining back to this session. The IPNSIG, or the Interplanetary Networking Special Interest Group, is a global organization with over 800 members that aims to expand networking into interplanetary space for the benefit of humanity. Today, you'll be hearing from some members of their board who will explain some of the projects that they're working on. First off, we'll have, uh, and I'm going to say his name wrong. I apologize. I'm gonna try my best. Yosuke Kaneko.
That's pretty close.
Yeah, I'm
That
trying.
was perfect.
He will be providing us with an overview of the IPNSIG and the overall plan and team structure, and also as chairman of the strategy and working group and lead the IPNSIG. He is also associate senior administrator at JAXA. After that introduction, we'll be hearing from Oscar Garcia, who is a board member and the pilot project working group lead at IPNSIG. Oscar presented the first medical record system for space exploration in 2020 and has received an award of the World Summit on Information Society and Digital Health and was nominated to the Arthur C. Clarke Award of the British Interplanetary Society. Oscar is speaking to us about the DTN research and experiments that the IPNSIG pilot projects working group is completing and their corresponding testing plans. Then after that, we'll have Scott Burley, who will be speaking on multicasting delay-tolerant video systems. Scott is the vice chair and technical documentation working group lead at IPNSIG. Scott recently retired from JPL, where he has been developing flight mission software since 1986. He's lead author for a specification in bundle protocol version 7, which, as Ed said, is to be released this week, we're hoping. Mr. Burley has received the National Exceptional Engineering Achievement Medal and 4 NASA Space Act Board Awards. Lastly, I believe Laura was able to join us, which is great. She is the head of data and AI for Google Cloud in London. She has received numerous awards for her work from entities like the Royal Academy of Engineering, MIT, and tech companies like Google, Intel, and Microsoft. Today, she will discuss her work on artificial intelligence, federated learning, and distributed servers on DTN. Also attending, as we know, is a member who always visits us and helps us with these DTN face-to-face is Vint Cerf. Vint, it's been a while since we gave you a nice introduction and a bio, so I'm gonna read your entire bio for the entire group, okay? so bear with me. So, Vint Cerf, who serves on a board member for the IPNSIG, at Google, Vint Cerf contributes to global policy and business development and continue the spread of the internet. Widely known as the fathers of the internet, Cerf is the co-designer of TCP/IP protocols and the architect of the internet. He has served in executive positions at the Internet Society, ICANN, the American Registry for Internet Numbers, MCI, and the Corporation for National Research Initiatives in Defense, or DARPA, and on the faculty of Stanford University. Vint has sat on the U.S. National Science Board and is a visiting scientist at JPL. Is a foreign member of the Royal Society and Swedish Academy of Engineering, fellow of the IEEE, ACM, American Association of the Advancement of Science, American Academy of Arts and Sciences, British Computer Society, Worshipful Companies of Internet Information Technologies and Stationers, and is a member of the National Academies of Engineering and Science. Lastly, Cerf is a recipient of numerous awards and commendations in connections with his work on the internet, including a U.S. Presidential Medal of Freedom, U.S. National Medal of Technology, and the Queen Elizabeth Prize for Engineering, the Prince Austrias Award, the Japan Prize, the Charles Stark Draper Award, and the ACM Turing Award, the Legion of Honor, and 29 honorary degrees. So Vint, I wanted to say that all, so we all know it's been a while since we read your bio to this group, so now we know, and we thank you for joining us as well.
Thank you for having me today. I appreciate it.
No problem. Thanks for joining. So we're going to kick it off first to Kaneko for the first presentation to give the introduction.
Sure, and thank you so much for the perfect introduction, and thank you for getting my name right. You got it perfect. I do have a couple charts that I want to show you as a starter, if I may. I am going to share my screen right now. Can you see it?
Yep.
Okay.
Yes, we can, Kaneko.
Okay, good. So good afternoon to our NASA colleagues once again. I'm Yosuke Kaneko, and currently chair of the IPNSIG. And as per the introduction, I also work at the JAXA headquarters, working closely with the Moon and Mars exploration programs within the agency, and also work closely with the Artemis as well. I used to work on the ISS program for more than 15 years, specifically in the field of avionics and software. So some of you might see me around, but it's certainly my first participation to NASA's DTN working group. And we're really extremely excited to brief you on some of the recent progress here at the IPNSIG. So before we get into a whole lot of details, I would like to start by giving you a high-level summary. Yeah. Okay. Okay, so some of you may be already very familiar with our group already, but we have more than 800 members today with the goal of expanding networking to interplanetary space. And as you can see in the pie chart, we have a very good distribution from each continent across the globe. Our memberships include the space agencies such as NASA, ESA, and JAXA, and also from the private sectors and also from the academia as well. And here are our board members. I currently chair the board, and of course, Vint and Scott Burley and Mike Snell, they've been in business with the IPNSIG for roughly 20 years already. And just recently, the IPNSIG has publicized a report, which is titled The Strategy Toward the Solar System Internet for the Benefit of Humanity, where this is really our very first attempt to lay out the various efforts, which we call the roadmap, where the roadmap is a set of efforts proposed by the IPNSIG, which might support the development and evolution of the solar system internet. And just touching briefly on our new vision statement, the IPNSIG really sees the solar system internet as a common structure for humankind, where our vision really addresses that in simple words, which is to expand networking to interplanetary space for the benefit of humanity. And then touching briefly on our mission statement, basically composed with the three pillars. First is to create a common vision for an interplanetary network with the stakeholders, and help and offer a narrative and roadmap in order to help shape the future of an interplanetary network. And the third piece will be to promote the technology, promote and increase the maturity of DTN through the use in terrestrial and also in space applications. And along these lines, the IPNSIG has launched a series of working groups where we have really broadened the scope of our activities by not just focusing on the DTN and bundled protocols itself, which you will be hearing us from us today mostly, but we really started to work on roadmap development, and we're also trying to formulate a new working group, which is called the Architecture and Governance Working Group, or the AWG. At the AWG, we will try to explore the key properties to realize a common solar system internet architecture, and also the supporting governance mechanisms that might support that architecture. We're currently in team formulation process of this working groups, but our European counterparts are from ESA and also from JAXA has already indicated their participation to this working group. And then lastly, I would like to briefly touch on the IPNSIG Academy, which we will be launching this year. It sounds like an institution, but it is an IPNSIG hosted educational program in order to promote the development of the IPN. The real goal here is to cultivate young generation's interest and expertise toward the development of the IPN, as we have a long way to go. What we're really trying to focus here is to familiarize the young with space communication technology like DTN, and also on policies, and also on the governance layer as well. And I think that takes us to our final page. We will have more details on the Academy and of course on the working group efforts on our webpage. So please visit us on ipnsig.org. And thank you so much for your attention. And with that, I would like to pass the torch to Oscar Garcia, who is leading the pilot projects working groups. So Oscar?
Hello. Thank you very much for the introduction from Philip and for the invitation. I would appreciate, Philip, can you pull up my presentation?
Yep, it's coming up shortly here.
Okay. Thank you. Well, my name is Oscar. I am the pilot projects working group lead of the IPNSIG. Working in this activity now for a year and a half as a project lead, and we have developed several projects that I would like to share with you. Next, please. What we are doing in the IPNSIG is to develop technologies with members of the working group in several continents to test and refine the DTN technology and the protocols, and with the goal to permit the communication between Earth and space. Next. What our infrastructure that is has been provided by the members of the working group. We have cloud servers running in AWS, Google, Azure. Some of that is in Europe. We are using the servers of Google for artificial intelligence that Lara, who is in the meeting, is also helping us with that. We have some developments of infrastructure that from Utica College and a testing lab that one of our members has provided also for that I will show. And there are a lot of personal computers that around the world with volunteers. In the next slide, you will see some of the infrastructure. Please, can you move to the next slide? Well, this is in Utica College with several supermicro servers with an e-main cluster node that allows to raise up to 200 virtual servers. And there we are working in testing interoperability between the different implementations of DTN. We are also using this in the testing plan. Next slide. You will see in the next slide this lab that was set up by Jorge Modio, one of our members. That is a group of different Raspberry Pis, personal computers, LoRa transceivers, GPS, several, and all are communicating now with DTN. So we are using this also to test applications that we are developing before we are expanding this to a bigger public. Next slide. Also, this is a list of the research experiments. Some of those I'm going to show in the next slides. Connection between clouds and DTN, interoperability, as I mentioned before, routing, security. One topic important for us also is the interface of DTN with different programming languages. We are launching a global testing plan in different locations. We made also an experimentation with several of the members, Lara included, for example, with an offset from the European Space Agency. We have made testing with robots, video DTN. Scott and Lara are going to talk about that, and federated learning. And the last one was what is called the Christmas Challenge that I will show you later. Next slide. In the projects, well, the first one that Vinton, Lara, and myself will work on that. That was in November 2020. That was communicating with DTN between the Google Cloud and the servers in Amazon Web Services. Well, it was, we consider an historical thing to do. There a link that you can review about this first experiment. Next slide. Also, this is the experimentation made in the European Space Agency. The idea was to, with different implementations, in this case, ION and D3TM, DTN, the connection was made and images were processed through the satellite. The bundles were interconnected between the two implementations. Then they were processed in Google Cloud with technology that Lara worked into, and the images that were taken were interpreted and recognized the images as words with artificial intelligence. It was quite an experiment, quite complex, and it took about 2 months of work. Next slide, please. Another thing that we are working, we have been focusing in the last time, is to set up a DTN testing plan that allows us to test the reliability of the different implementations in sending bundles to start between different locations around the world, but in a constant process. That is the idea. The next step is going to be to incorporate network management, bundle security, and we are trying to connect all the implementations in this project. Next slide. For this, this is more or less the idea, a diagram of that. You will see also when these slides are shared. Next slide. The idea was also to develop a complete system that has registration forms online, software that can be downloaded, installation manual, user manual, a support form. We have a small team that is growing of support personnel that are volunteer members. And we want to have also the feedback, and we are sending to the users the feedback of the bundles they are sending. And as you can see, there are graphics there with the manual and forms and all that, with the idea of generating this information in a way that can be published. This statistic can be published in our website and others. Next slide, please. Well, this is a map of the locations that we're working for now. We have in North America, as you can see, we have in Mexico, in the United States, Mexico, and some in South America. We have some locations in Europe starting, and also we are trying to install something in Asia. So we are going to have more or less a global, and we want to have a lot of dots here with all with the green color. That would be that they are sending bundles and connecting between them. Next slide. Well, this is what was the Christmas challenge that was developed by members of the project working group from Spectrum Corporation in the United States and from Sweden, Samographic. There's a group there. It's important to know that this, what you see there is the Santa Claus sledge, but this was in Sweden in the snow, and connected to Raspberry Pi, and a command was sent on DTN to turn the lights of the sledge on and turn them off. So we say that Santa was in Sweden in the darkness, and well, we could send the this command, and Santa has the lights to start his journey. So this was the Christmas challenge, and it worked on December 23 last year, just for Christmas. So the presents could be distributed to the kids. Next slide. Well, besides these experimentations or research, we have some applications that we have been working. Well, medical records that was mentioned for exploration, that is a development that I did myself. The nomad track for reindeers that in the Arctic, crisis management system, and DTN network management. I'm going to show some of those. Please, next slide. This is a development by Spatial Corporation, the engineer Alberto Montilla Ochoa and Alberto Montilla Bravo, that allows working with ION to generate in a very automatic way the contact plans without we all write this by hand with a lot of work, and this can generating the endpoints and the numbers of the endpoints. This builds automatically the routing and the files to make it easier the connection. Next slide. Well, this is also by Spatial Corporation, the crisis management system that is intended. It has been working in beta testing with the use of drones and mobile applications to be useful in situations, in crisis situations where the communications cannot be the regular communications like cell phones and others are dropped. Then this system is intended for this resolve this situation. Next slide. Well, this is a project. To be clear, the group in Sweden is working in the Arctic. You can see there, perhaps if you look carefully to the picture, you can see there the ice covering the antennas. So it's a very challenging conditions that with the use of LoRa DTN and ION DTN and Raspberry Pis, they are following reindeers, what is called reindeer husbandry for the Dalvadis Economic Association in Sweden, and with the Luleå University. This was a project that has several years of development and is operational with all this technology. Next slide. Well, and this is something that I care very much because it's medical record for space exploration. I've been in the digital health and medical record systems for 20 years. As Philip mentioned, I have been awarded by the World Summit of Information Society and all that. So the idea and this project is operational as well. We don't have still astronauts using it in the space station, but this perhaps we can get some volunteers from some of these conversations. Is to connect the healthcare system in Earth to the healthcare system in space. Our technologies and others technologies in healthcare to record medical records use TCP/IP. We develop a gateway that makes a conversion between the medical records in Earth to a medical records in space, and we develop also the software to be used in space in computers with not so big power, so it can be run in computers even in console screens. This is quite complex in its development, and we can make a full or 2 hours of explanation of this. So next slide. Well, here there's this report that of all the job that we have been doing during these years. If you wish to download, if you have not received that, click in that link or copy that link. You can download the version. In this case, we made an update for this meeting, so we will be very glad for you to read that, enjoy that. Next slide. Well, for collaboration, we have there our websites, IPNSIG.org, and we also have the blog of the project working group, where we have also contact form, and we try to respond and follow up with all the connections. Next slide. Well, and these are the points of contact. Yosuke Kaneko, Vinton, that you all know, Scott, and myself. And for you to keep up with this later in the conversation, I can show this again so you can take note. And finally, next slide. Thank you very much. Oscar Garcia, at your service for any consultation and to work together. Thank you.
Thank you, Oscar. That was a great presentation. We'll have some follow-up questions, but we'll move on to the next one, and maybe at the end we'll circle back with a few questions.
Absolutely. Our next speaker is Scott Burley.
Oops. Good. Thanks, Oscar. My presentation will be pretty brief. Actually, before I start, there's something that I had completely forgotten about until we began today that I wanted to get in a plug for the technical documentation working group of IPNSIG. There is now a quite good, well-organized library of DTN documents available at the IPNSIG website. So if you go to www.ipnsig.org, there's a big red button on the upper right that is labeled library, and it'll take you to the library that the working group has been putting together for the last 6 or 8 months. It's a useful research tool, I think, for people who are working on innovative concepts in this field. Okay, so now on to the presentation I plan to make. This is going to be a few slides on multicasting delay-tolerant video streams. And can we have the next slide, please? This really goes back to work that was done by Lee Torgerson and his guys at the Protocol Technology Lab at JPL in 2017, 2018, developing an interface between VLC for video display and the ION implementation of DTN. That VLC ION interface enabled VLC to stream video over DTN using an ION source node that used the bundle streaming service protocol underneath BP, so that an ION destination node could accept the bundles and use VLC to play the video. And it could also be used to stream reconstructed video, that is video that had been filled in any gaps by BSSP retransmission from the BSSP database, so that the reconstructed video could be viewed. As Josh Deaton pointed out today, there is now an arguably more fully integrated mechanism for doing this sort of thing. The use of the RTP protocol directly on top of the bundle protocol. But the key here is that delay-tolerant video streaming is an idea that is fairly mature by now. Next slide. Well, the other piece of multicasting streaming video is the multicast part, and this slide just briefly illustrates the concepts for bundle multicast that were developed based on some research done by Olivier de Jonquere in 2020 that is has been in ION for about a year and a half, 2 years now. And it's a very simple multicasting system that doesn't require management of multicast distribution trees. The distribution trees are self-forming and self-modifying as the network works through its contact plan. It's quite ingenious, I think, and I think Olivia did great work on this, and it's quite efficient. Next slide. So the combination of these, we exercised for the first time last year. Lara can answer more questions about just exactly how she did this, but Lara Suzuki of Google managed to get delay-tolerant video stream multicast to multiple receivers as of last June. And I think an example of the sort of use case that she had in mind was multicasting inspection videos for collaborative analysis on multiple machine learning elements that could all examine portions of this stream of video and agree on what might be causing an anomaly in a piece of equipment. Next slide. So you have to bear with me for a couple of slides here because we do come back to multicasting video streams in a minute, but I need to take a brief detour into more on multicast. Other uses of multicast, one of which is optional automatic replication of contact plan changes across all of the nodes in a single network region. Which has been difficult to coordinate manually for a long time. And since ION 4.1.0, we've been able to do that automatically using a variation on bundle multicast that distributes data to nodes that are sort of automatically members of the artificial multicast group that is the set of nodes in a single network region. Also, for about a year and a half, 2 years now, ION has included a trusted collective system that implements what I think of as sort of the delay-tolerant analog to what we do with servers in the internet. It's a trustworthy delay-tolerant aggregate authority for distributing critical but non-confidential information. And it's really derived from the original design for DTKA, and DTKA has been adapted to utilize this core functionality that's been extracted out of it into collective system, trusted collective. Next slide. This is just a picture of how trusted collective works to explain how multicast is used in it. The source of this critical data that needs to be distributed in an authenticated way multicasts these records of new data to the multiple nodes of the distributed authority. Each of those nodes receives those records and adds them to a database, and periodically another task running on that node reviews the pending records, composes a proposed bulletin of new information, and multicasts the bulletin to its peers, the other authority nodes. The peers reconcile any differences among the proposals, the proposed bulletins that are multicast, and arrive at a consensus bulletin. And then the various nodes of the distributed authority publish assigned subsets of encoding blocks derived from chopping up that bulletin. And those bulletin blocks are multicast to all the client nodes that are interested in that information, and the client is then reassembles the bulletin from received multicast blocks from multiple nodes, so that no single node can distribute bad information that would be internalized by other elements of the network. Next slide. So, given that trusted collective capability that is used to distribute public keys, public encryption keys, there's a new system called delay-tolerant node auto configuration that is able to automatically instantiate a new node in a trusted and authenticatable way, and having done that, deploy the node to remote machines elsewhere in the network, so that you can rapidly construct a fully functioning delay-tolerant network. Next slide. So that capability was used to build the regression test case for interregional forwarding that was just been developed over the last couple of months, that enables a delay-tolerant network to be divided up among an arbitrarily large number of regions, each of which contains a small manageable number of nodes, so that you can grow the network to arbitrary size. This too relies very heavily on multicast in order to do the probing of the region topology that results in self-discovery, automated self-discovery, and automated management of interregional routes. Now the last slide next is sort of the culmination of all this, is that the interregional forwarding implementation includes interregional multicast, and that operates by multicast group membership petitions arriving at a passageway node between regions. And when that happens, the passageway becomes an ex officio member of the group on behalf of the members of its region, and re-multicasts that membership petition within its other region, so that petitions are node membership, group membership is disseminated throughout the network in a scalable way, with nobody having to know that 6,000 other nodes are members of the multicast group. When the multicast bundles themselves similarly are delivered to passageway nodes that are ex officio members of the group, and those nodes then multicast within the other region that the node is attached to. So taken all together, all these things add up to, I think, a system that ought to be able to support delay-tolerant, reliable multicasting of streaming video from space to really any number of viewers. I think it's a capability that could be really valuable in the years ahead. And that's the end of my presentation.
Thank you, Scott. Good information there. I definitely see some great applications.
And we have,
next we have, I'm sorry, go ahead.
You have Laura is next, yeah.
Yeah, let's go to Laura, and Lee, we'll circle back to you, okay?
Okay.
Okay, guys. I will show my presentation. Can you guys hear me? Can you guys hear me?
Yep, we can hear you.
Okay. Can you guys see my presentation?
Yep.
Yep.
Okay. Is this moving? Like, can you see something moving here?
Yes, we do. It looks like it's working
Okay,
out.
good. Okay, just checking. Okay, I just want to very quickly introduce a little bit of the research output we have done in terms of using DTN-ML. That is DTN powered also by AI applications and also by federated computation. So we have achieved using in IoT, also using multicasting for image recognition, for video intelligence that will recognize what is presented in videos frames. Also to do visual inspection to analyze what, if there are any dents or any defects in outside structures. And that is also run on Kubernetes engine. We also have the object detection on the edge that is using also multicasting. So we have Raspberry Pis and Arduino doing that, and also federated learning via DTN. I have done that over like multiple clouds, Azure, AWS, and Google Cloud, using multiple protocols as well, and implementations of the bundle protocol, and also using Arduino, Raspberry Pi, and Kubernetes, and TensorFlow. And there are available 17 repos online. So if you search for La Suzuki on GitHub, you can find my GitHub available there. What I would like to talk to you guys is more about introducing what DTN-ML is on, that is augmenting space ML through federated computation. So much of the data that we have is born decentralized, and billions of phones and IoT devices constantly generates data that can enable better products. It's easy to learn from data in a centralized place. However, centralized learning introduces latency, intermittency, data caps, and battery life issues, and privacy concerns. We can do all the ML training on device, but that limits the creation of new experiences. There's often too little data per customer, or customers are not contributing a lot to the machine learning process. So decentralized learning supports the machine learning learning ability in a collaborative way. So we have many extensions for decentralized learning, that is like using differential privacy to ensure that we cannot identify devices by themselves. We also have compression and quantization that enables us to minimize the cost of network transmission of machine learning models. And this approach is generalized beyond model training, also for evaluation as well. We can do model evaluation in a decentralized way. So introducing DTN-ML. So DTN-ML is an end-to-end network service and federated computation capabilities that will provide on-cloud communications over DTN, also using federated learning to learn from data in a way that data does not leave the edge devices, they remain there. And then we can only process through the networks the weights and biases of those models. So this approach is more suitable for applications where we have intermittent connectivity, variable delays, high bit error rates, and asymmetric and simplex links. And one of the things that we also have is like we increase space link efficiency, utilization, or robustness by enabling more reliable and efficient data transmissions that will result in more usable bandwidth and the ability to do more science in space. So in here I have a demonstration of like the DTN workflow. So our approach is catered where data is distributed across several devices in a highly uneven fashion, and where devices have significant higher latency, low throughput connections, and are only intermittently available for training. So we firstly initialize a model, a global model in the cloud, which is then downloaded by the devices, the edge devices running on DTN. So we have the contact graph. We also have our SDRs over there. And then those models, they are firstly downloaded by those devices. And what happens is they collaboratively learn on a shared prediction model while keeping all the training data on the edge, decoupling the ability to do machine learning from the need to real-time streaming heavy payloads to the ground antennas and be idle while waiting for a response back. So basically, after we train that models online on the edge, we can transmit those to the servers. And in those servers, we are going to have a combination of those metrics that we collect from the devices. For instance, the biases and the weights. We produce a new model that is learned on a collaborative way, and then we distribute this to the device themselves. And that process continues until we also have like a refined more refined model. So this is a demonstration of us like training on the edge using TensorFlow Micro for microcontrollers, or TensorFlow Lite for other like different processors with more capability. And then after we train on the edge, we transmit that data over to the server, and then we produce a new model that can then be shared across the network. And that can be that can allow data scientists and mission control operators to deal with implementing AI applications in space while ensuring quality and of the science they are doing in terms of AI by learning in a decentralized collaborative way, and ensuring that we have more available CPU and battery, so there's no impact on devices performance. And the fact that DTN-ML with federated computation is automated, the protocols automatically perform many of the functions that otherwise would have to be commanded by mission operators. So we enable the reduction of cost, risk, and effort involved in communication over the spacecraft. So that is the focus of my research now, that is working on how we can make tap into the power of federated computation to do more specialized machine learning models on the edge devices that we have in space. So that's me. Thank you so much.
Fantastic. Thanks so much, Shalara, for joining us. I'm glad you could make it. It's been...
Hi.
Yeah, thanks for joining us, Laura. Glad you're able to make it as well. Great information, and I'll let you guys, if you have any additional information, we can take some questions. Also, I'd like to personally invite you all to, we have a SCAN program technical forum that we do with a different community, including the Artemis folks and the Gateway and other folks. And so Brenda mentioned that before, that you wanted to invite you guys to that forum as well. So we will chat with you and make those arrangements to go to a technical forum that we have later this year, if that's okay. But I'll send you details. We'll follow up on that one.
I noticed it's been Lee Torgerson has had hand up.
Yep, Lee, I think you have your hand up. Hey, Oscar, I'm gonna mute you for a second. I think we're getting a little bit of feedback.
Yeah, okay, we got it. I was had my hand up in reference to Scott Burley's mention of BSSP, and if there is time and anybody's interested, I have a 5-minute video that goes through a full demo of the BSSP protocol with video streaming from one side to the other through a relay with link errors and so forth. So if you're interested in that, I can do it now, or we can do it some other time.
It's been, well, we have, what, another 11 minutes. A suggestion, Lee, is that something that you could allow us to download and watch at our leisure?
It's not narrated. I'd have to do another one where I narrate it.
Oh, I see. Okay. Well, I'll tell you what, we've got an hour tomorrow morning when we could pick up some Q&A. So why don't we watch your video? I mean, what nice end of the day, you're going to watch a video and have a drink.
Yeah, I believe we're going to invite all the folks at IPNSIG for your 1 hour tomorrow that we have for the DTN considerations tomorrow morning. So
we can have, because I'd like to use tomorrow to talk more about what we can do together with the NASA working groups plus the DTN groups, I mean the IPNSIG groups. So
that's perfect.
So Lee, why don't you run video?
Okay. I should be sharing my screen, and can everyone see the screen?
Yes, we can. It's a little hard to read the fonts.
Yeah, unfortunately, we're trying to get three computers up with 4 terminals each. on one monitor is difficult.
I can tell you, Lee, that Laura Suzuki is very familiar with this problem.
Indeed.
Well, I'll start this real quick.
We do,
So I've
we
got
do that. We do that.
I have a spacecraft sending machine on the left, a ground relay machine in the middle, and a ground receiving machine on the right that's going to be receiving the video. So the way BSSP VLC works, which I've got a slide tomorrow or the next, whenever it is, that'll show you, that'll give the directions on how to download this software for your own use. It's available on JPL download site. So I'll start it and just show how you use this. So starting over here, you have a BSS VLC receive mode 3. You give it a name, some parameters, and I put it in a script so that I wouldn't have to keep typing all this stuff in. So when you run it, it says BSS reception thread is running. You start up VLC, you tell it to open a network stream. You go over to it and say, listen to UDP localhost port 1234. That's just comes with VLC as stock default. You can see the yellow bar pulsing back and forth. VLC is waiting for video. On the sending side, we go send, and you note that there's a port number, 55569. What this is going to do is it's going to send video to, VLC is going to send video to port 55569 on localhost, and this software is going to put it into DTN for mailing to the ground recipient. So I'm going to grab a quick little clip, 90-second clip of presentation we did like 8 years ago when we did the DINET experiment. So you put in you tell VLC to stream the data file to the local host, and here's where you put in the port 55569. And then when you confirm that, turn off transcoding because we want it in the same TS format. Tell it to stream the data, and it starts streaming. And then you can see the watch characters it's streaming, and on the recipient side, you can see the videos being received, and this is what you're seeing in real time. And this was the epoxy spacecraft that we did the DINET experiment on. Vint was explaining it, and now I'm going to go over here in the middle, and I'm going to turn off the relay machine. And so there's Vint about to explain it, and then we turn the machine off, the relay off. We don't know if the spacecraft hit Vint or not. And then I turn it back on. Well, we don't know because it just pops right into the next segment where he's continuing to explain DTN. This is a very excellent video. You can see the watch characters are starting to look disturbed, and that's DTN resending missing data. I've stopped the downlink again, and now I brought the downlink back up. This is kind of the worst case error scenario with where you lose the link entirely. And pretty soon the videos, my 90-second clip is going to be over. I just excerpted 90 seconds out of this probably 8-minute video from the epoxy experiment. So once the video is stopped, come on, stop. It's got a few seconds left to go.
Yep.
There we go. So when the video stopped, you see the relay stopped, the watch characters stopped, and now Vint has stopped. And so what we can do on the receiving side is that the BSSP software and the BSSP VLC software, if I list the directory I ran it from, notice it's come up with testvideo.dat, list, table, and .ts. Now the .ts program, if you open that up with VLC or any other program and play it back, that's just a repeat of exactly what you saw in real time. And unfortunately, VLC keeps maximizing itself. So I have to fiddle a little bit here to get it. I won't show the whole thing, but this is the clip that we were seeing in real time where the disruption occurred. And here's the spacecraft about ready to clobber Vint. And then it freezes, and we hold our breath and hope it doesn't hit him. So we'll stop that because we've already seen that. Now we can reconstruct the data with BSS VLC mode 3, and we tell it what to play. And if I go to the here it is, mode 1. You give it all these parameters: the start time, end time, the name of the file you want to stream the clean video into, and you run that. And then that goes into the database, and it takes the reconstructed video with all the missing data and builds it into a clean video.ts file. And if we play that in VLC, the one thing you'll notice under File, Open File, notice it's 20 megabytes, and the original disrupted video is 16, so we recovered 4 megabytes worth of data. And then the end of the demo here is just playing that. This is the pristine reconstructed data at the receiver. And you can see that when the epoxy spacecraft gets bored with the comet and comes back around to try to fly into the back of Vent's head, fortunately, it just does a nice fade into the next segment, and it doesn't actually hit Vent. So anyway, that's the demo in a nutshell.
Thank you so much, Lee. That's great.
Fantastic.
We're almost out of time, so let me make a suggestion. First of all, I want to thank Kaneko and Oscar and Laura and Scott for their presentations. I know that Philip, you would normally do that, but I figured they picked up for me when I was going to try to do some of this, but my wife is recovering from surgery, so I've been distracted. What I'd like to do tomorrow, though, is to explore ways in which the IPNSIG group can be beneficial and supportive of the work that NASA and the other space agencies are doing. We would like to promote and demonstrate the DTN program and show their utility both terrestrially and in deep space. We'd like to help verify various implementations of those protocols so that we have confidence that when they become off the shelf available, that when NASA and the other space agencies ask for this capability, they have some confidence that the installed off-the-shelf base will actually work. So we don't want to compete in any way with what's going on at NASA, ESA, and JAXA. We want to be supportive and reinforcing of that, and to promote the efforts that have already been underway for 20 years now. So tomorrow, maybe we can identify specific people that can get connected to figure out things that we can do together that would be mutually reinforcing and advantageous. So that would be my proposal for tomorrow's discussion.
I think that makes sense. So tomorrow at 10 a.m. Eastern, when we'll get started, we'll open up with that. And the questions, I have a few questions. I'll hold off until that discussion as well. And we'll go from there. I know Josh had his hand up for a while, so I was going to say, Josh, did you have anything you wanted to bring up now?
Yeah, just a quick thing before we bounce today. Scott, in relation to your BP multicast work, are you working with any standards body right now to try and get anything going with that?
Can't remember whether it made it into the rechartering of the DTN working group in IETF or not. There were many candidates for work that people wanted to do in the recharter once the initial 4 RFCs were issued. And multicast was one of them, but there are a lot of others, including people want to explore routing and naming and addressing and a number of other things. So I think it's very important, and I will continue, agitating to get it added to the program of work. But I have no confidence that we're going to see an RFC for bundle multicast in 2022. It's possible that we would make some progress next year.
Okay, I was just going to say, us guys over here at Marshall, we are currently working to basically replicate what ION has for the multicast stuff, and also provide some potential different ideas of how it could work. And so just trying to see where we're at and see where we can collaborate for that.
I think that's terrific because, you know, this has been the thing with IETF from day one, right? Rough consensus and running code. You know, if we get some running code and we can reach sort of some consensus on it, that takes us a long way toward being able to establish a standard. And I think that'd be very valuable for everybody.
Awesome. That's it for me for now.
Thank you, Josh, and I appreciate the discussion. Oscar, I'll let the folks give some closing words.
A short topic that is we are very open to questions or exchange with all there's a lot of persons here in this meeting, and I'm sure there are many things that arose in this conversation. So you can send us an email, send us a contact form, connect through Philip, through Wendy, through anybody that I'm sure you are in touch. So well, we are open to that.
Great.
Perfect.
Okay, everybody. Well, thank you again for taking time to join us. And I will see you, we will, hopefully all of you, tomorrow at 10 o'clock Eastern.
Thanks, Vint. We'll see you tomorrow. I wish your wife the best and speedy recovery.
Thanks so much.
Everyone, we'll see you all tomorrow, bright and
Thank
early
you.
for some.
Thank
Thank
you very
you.
much.
About exercising the bundle protocol suite. Our purpose is severalfold. The first one is to promote the use of the bundle protocol and the concept of the solar system internet to anyone who's willing to listen, especially the 800 members of the IPNSIG who are scattered around the world, as you could see from yesterday's presentation, but also to parties whose success in space vehicle construction might hinge very much on having good quality implementations of the bundle protocol. And so that would include companies like Lockheed Martin and Boeing and Ball and all the others that we typically have dealt with to build spacecraft for space exploration. But in addition to wanting to show that this technical system works at scale, and that we are able to exercise and demonstrate the strength and utility of the security system and especially the network management system, we'd like the general public to have a role to play. So some of our pilot projects involve drawing general public interest. And many of you heard me talk about the previous very successful SETI at home, Search for Extraterrestrial Intelligence at Home, application which allowed people to run programs to analyze the radio signals that were received. We're not quite we're not inviting the general public at this point to get quite that deep into the bundle protocols themselves, but we'd like to be able to have them run programs that would at least generate traffic, which would lead to substantial amounts of bundle protocol flow. We'd like to be able to experiment with different topologies, different latencies, and connectivity schedules, contact graph schedules, in order to confirm that the system recovers well. And those of you who were on the call yesterday saw Lee Torgerson's example of an ability to recover from loss of signal and to retransmit all of the data so everything ends up where it needs to be. There is another thing, though, that I'm pretty sure most of you will have an interest in, and that's the question of what happens if this is successful. What happens if we show that the technology can be used to build a solar system scale internet? What happens if Musk and Bezos and others are successful not only in launching near space activity, commercial activity, but also the Artemis mission and the Gateway missions showing success on the moon? We believe that there is a latent interest in commercialization all the way up to and including things like mining on the moon or possible mining on other parts of our solar system. And so the question arises, what are the rules of the game for operating in that mix of commercial and government and private sector enterprise. We have a treaty, for example, a space treaty, which was intended to reduce the likelihood of militarization. I'm sorry to tell you that that unfortunately has not succeeded, and that we know that there are a variety of devices that are either in orbit or capable of being launched from the surface to interfere with space operations. So we're already past that red line. However, there's some hope here because the Artemis Accords, which the former chief scientist of NASA summarized for me recently, Jim Green, suggests to me that that's not a bad basis on which to explore what the rules of space should be as we contemplate commercialization and expansion beyond the moon and to Mars and other planets and other parts of the solar system. So the idea of exploring what that legal architecture could look like is an important one. And associated with that is the question of how the solar system internet would actually be operated. Certainly in its early stages, essentially the space agencies will be cooperating with each other, possibly to run distinct components of a solar system internet, which then has to be interconnected in the same way that separate networks of the internet are interconnected at border gateways, with the whole idea to allow this concurrent operation of independent entities. I'm still not 100% clear that we know exactly how that's all going to work, although Scott Burley will certainly tell you that in his head anyway, there's a notion of internetting in space within the concept of the solar system internet and the bundle protocols that would support it. The idea of passageways between networks is comparable to going through border gateway routers in the internet. So we want to explore operationally what that would look like, and we hope that we could contribute to the documentation of I would say, strategies and tactics for designing an operational framework which allows this kind of flexibility, multiple parties engaged in providing resources, sharing resources with each other, while still retaining control over the assets that they presumably spent a lot of money to get into position. So what I'm hoping we can do in this session is not necessarily come up with a list of action items exactly, but I would like it if we could identify parties who should talk to each other about possible collaboration between the IPNSIG team and the DTN working group at NASA. So that's my overall summary of what I hope we might get out of this discussion. And I will say that it's not absolutely necessary to consume the entire hour that you've allocated for it. I know that you often run overtime in the other sessions, and I won't be disappointed if we end sooner. But let me stop there and first ask if there were questions from yesterday's presentation that you'd like to raise. And second, have you any reaction at all to my aspirations summarized in the last 15 minutes or so? David has his hand up already, so why am I not surprised? Yes, David.
Hey, Ben. Good to see you, and welcome to the IPNSIG. So I guess the part about the having the multiple providers and the network and figuring out how we're going to do that, I just want to emphasize the importance of that, because as we're moving forward with what's now being called the LunaNet, it is clear that that is the approach that we're going to need from the beginning, right? Because we have all the different international agencies and even different pieces of NASA and commercial folks all, in some ways providing, there's a danger that they're all going to provide their own systems, and now we're working hard to try and get them to at least put networking in those systems. And then once you have networking in the systems, then we want to be able to have everybody interoperate with each other's systems. And then next thing you know, you have different people controlling different parts of the network, and you're trying to make a big network out of it. So it doesn't look like we're going to have a phase where there's, like a single network provider and then maybe other people come along. It's like right from the beginning, we have to put some basic things in place to allow that large cooperative structure to happen.
Right, and so thank you for emphasizing that. I would point out that a desirable property of whatever we end up with is that those who own assets have the control of those assets and are able to make the assets available under their control, so to speak. A trivial example of this would be to say that if you had a device that could act as a relay in the solar system internet, and you made it visible by making it visible in various contact graphs that other relays would know about. In a sense, that's one way of announcing your presence and announcing the availability of the asset. And that's a very simple example, and I don't mean to suggest that's all we need to do, but it's the kind of mechanism that allows the holder of the asset to decide, do I put it into the contact graph and make it visible to others or not? And I could even say I'm not willing to have it visible in contact graphs A, B, and C, but I am willing to have it visible in contact graphs D, E, and F. So that's one obvious conclusion to reach from what David was saying. The second thing, which I also frankly worry a lot about, is what does network management look like in this mixed environment? We can certainly imagine using a network management tool to control the assets that you hold, but might there be common assets operated by a common agency or not? I think of United Airlines and the Star Alliance. Some of you have seen the jets that are labeled Star Alliance. Those are assets purchased by the collective and made available to anyone on appropriate request. So these are all kinds of complexities that we absolutely should include in our discussions in the DTN working group. IPNSIG would like to participate in that as well. So,
I do have my longer list of things for us to collaborate with IPNSIG for, but I'll save that for another meeting. But in general, I just want to thank the group for all the energy that they've been bringing to DTN. That the last year or two. It's really stepped up, and it's been excellent, and it's really just in time because this is now the window with trying to get internet in place, and what we're doing with the near space network is kind of like have to get these things in place very quickly and prove that it's going to work. Otherwise, we could get overrun by events. So thank you.
Thank you very much. Oscar, go.
I would like to add something that about David concerns, and we have been talking about that in several of our meetings. One of the situations is that some of the implementations are open source or public, and others are proprietary or under the control of with the understandable of the space agencies. One of the ideas during this concept of the testing plan that we are trying to expand is that some of these implementations can send bundles to each other without sharing the code between them. And that could be an idea that could test, at least on Earth, that these bundles can be received by each other, and with the concept that you were saying, David, that at some point where in space, these different implementation would have to connect between each other, but without sharing the software code that is like we do today in the internet. You send a TCP/IP packet from Apple to Microsoft, it has been always saying that of the neutrality of that packet. I think that we have to work on that, and that's what we are trying to work on.
Great, thank you.
Thank you, Oscar. Philip, your hand is up. Was that an old hand or a new hand?
No, I just had a few points I wanted to ask about.
Okay.
One is just the first part. I think we get a little feedback here. Maybe that's me. Okay. Yeah. So I think one of the issues I think we've always had and where we've been battling with was getting started. You know, I think especially with DTN and the Artemis plans that we have, we've been working hard on getting things running. You know, I always felt that once we have things in place, once we're using it in our lunar relays and our systems, we'll have an easier path to expand and have a nice a system where there's everybody collaborating together and using their assets. But I don't think the startup cost, the startup whatever it is been the hill that we have to climb to get things started has been a big challenge. And so we definitely need to try to get there and figure out how we can get past that barrier. And I think once we have it in place, I think we'll have a little easier road to expand to get to that internetworking approach. And just we go back to that one, but the other one I had was just about the health records from Oscar's presentation yesterday. And just I'm not familiar with the health records too much, but I'm assuming the health records and the networks that are used terrestrially are similar to bank records. Is that true? And that they have a network where they're able to collaborate between hospitals? Is that similar to a banking network system, or is that different?
That's quite a big question for an hour or two, but interoperability between medical records has been an issue for many years, and it still is. If you have seen during the pandemic, there was quite a problem of us to get verifiable statistics, because these medical records are quite proprietary, and there are some protocols. I have been working in this for 20 years constantly, for near 35 years before that. We have developed a model to interconnect different medical records of different sources. For you to have an idea, even if you go to different laboratory tests, you are going to get the results in a different way and order the lines in a different way. So what we have developed for many years is a way to interconnect all this. Some years ago, when we talked with Vinton in my city, in Mar del Plata, during an ICANN, we started to talk about this and about the need that we were working also of a DTN model to prevent that if you don't have connection or connectivity, the medical records are still available. You don't have that kind of problem if you're watching a video for fun, but medical records need to be available constantly. So, to go to a space in the presentation that we did last in 2020 of our medical record for space exploration, our concept is to be able to interconnect the medical records on Earth between the different technologies that are available, and that implies a lot of because the way of saying things in medicine between, for example, the United States and other countries, even talking in English, are different. In the UK, for example, so you have to compatibilize all those. And we developed a model that with DTN we could transfer that to space. And I did a testing with my own doctor I sent my medical record to space, that has another software, another client, and the captain of the spacecraft made like a consultation to my doctor, and it went back to Earth. And my doctor answered, and it went back to space. So just to show the idea. I don't know if
Yes.
I answer more or less. And one topic that I would like to mention, watching the presentation yesterday, is that we are looking forward. I have already transmitted images, static DICOM images to space, so to say. And I would like also to test with the DTN video technology to transfer, for example, to make a diagnostic of a catheterism or any kind of video image, with the same technology mostly that we show things online. So well.
Okay, thank
I
you.
get enthusiastic with that. So.
Thank you, Oscar. Let's see, Lee Torgerson had his hand up for a while. Lee, you're next.
I was just going to mention two things. One is I'm doing a lot of collaboration with Laura, and we've got a number of different ideas and projects in mind, some of which are mainly for her work and for the things that she's doing for Google, and some other things we're looking at additional collaborations. One of my themes you'll hear later is that if I'm working with network monitor and control software, I'd like real network traffic to try it with. And the same thing when I'm doing end-to-end demonstrations. I'm setting up a system to show some project how their spacecraft and instrument telemetry can flow through a DTN network and arrive at a scientist's desk. I like to have real instrument data, real science data. So I've been kind of like Tom Sawyer getting Becky to paint the fence. I'm trying to promote any kind of external collaboration possible where I can use other people's traffic. So I planned on setting up several machines, VMs, on the DIN when COVID allows enough of us to get into the lab to put the new equipment on the racks and hook everything up, and then I'll be collaborating. I'll get those machines working, and we can start working with IPNSIG on that.
So this suggests to me that Oscar and Lee would usefully get together on various and sundry projects. It also suggests to me that we need to figure out how to operate multiple and independent bundle-based networks while we're going through these kinds of experiments, so we don't collide with each other. So I think that the implication is that we will have more than one bundle network operating while we're running through a bunch of tests and doing interoperability testing and the like. But it would also be nice to have a network which represents the solar system internet in our experiments as a shared asset, and to see whether or not we can make the management of that shared asset work. So let me turn to Scott Burley and Ed Barain next. Scott?
Yeah, oh, I'm trying to turn my video on. There it is. Going back to what Dave was talking about and the necessity of starting off with multiple networks that then need to be integrated. I just want to suggest that the region concept that I based that interregional forwarding implementation I was talking about yesterday on, the essence of it is defining a region as being a collection of nodes that have a common mutual routing fabric among themselves, and not necessarily to the rest of the universe. And that common routing fabric, I think, typically is going to take the form of the information in it is going to take the form of what we're using as contact plans now in contact graph routing. Maybe not using contact graph routing algorithms, but I think the information that you need is pretty much the same no matter what mechanism you use for computing the routes. And in that sense, the management of that contact plan is an administrative task that properly belongs under the authority of some organization, and the points of passageways between regions, where regions correspond to contact plans, would be the points of negotiation between organizations that are operating these functional subnets of the overall network. Somebody asked me a while ago what the basis for aggregating nodes into a region would be, and I hadn't thought about it very much, but it really comes down to the basis for it is really organizational and administrative. The set of nodes that are under the administration of some entity would be the nodes that would be included in a contact plan and would be administered by that entity, and therefore the hierarchy of regions that's contemplated in that that region concept really maps to an org chart, and the passageways between regions going through that org chart through that network correspond to the org chart relationships for a large organization. Joining an existing region hierarchy would be a matter of negotiating passageways between the regions that you administer yourself and the regions that that your peers are administering. So I would just suggest that a way to explore these questions would be to get some experience with the interregional forwarding software that I hope is going to be integrated into the next ION release. It's available now as if you want to take a snapshot of it, it's up on SourceForge, but it'll take some time, I'm sure, to have it integrated into the ION baseline.
Thanks, Scott.
Just real quick on that subject, if I can, just for anybody that's I guess looking to demonstrate something or set something up or do a bit of the exercise that Scott said, I guess the scenario I'd like to put out there is where you have a user on the surface of the moon, and they have data that they're trying to send back to Earth, and at one point in time they're talking to provider A's relay. At some point later, it's provider B's relay, and then the ground station on Earth maybe belongs to that same provider, maybe not, and then also you can toss in like another user on the moon where they're trying to route data to each other, right? So in some cases the user is sort of stationary on the moon. It's all the providers that are coming in and out of view is actually what's the mobile where the change is happening, right?
And you're right. That's exactly the sort of scenario that I think the region concept that I've been talking about would support.
Right.
So
good.
It's been just want to observe that we need to put in place fairly quickly then the way of assigning identifiers to the nodes of the DTN. And that sounds like a very high priority if we don't already have rules in place for that, that take into account multiple owners of assets, multiple operators of those assets, and how they are assigned identifiers and how they are used. One of the guys who's got his head around that is Ed Bahrain, who has his hand up. So why don't we hear from Ed next?
Before we move on to the other stuff real quick, in regards to the region concept, Scott, have you played around much with having multiple boundary nodes for your regions and whether that introduces
absolutely.
any weirdness?
Yeah, well, that's a topic that would take some time to discuss, but yeah, the regression test in the distribution that I put out a few weeks ago it includes just that regions where there are multiple passageways from the region to other regions, or multiple passageways between two regions.
Copy. Would you be able to send that to me, Josh, over at Marshall?
Yeah, sure. I'll send you a link to. You can take a snapshot of the distribution and play around with it.
Thank you.
Okay, sure. Okay, Josh. Ed, you're up.
Excellent. So I just wanted to share sort of an observation and an aspiration, and also to say that I just completely agree with everything that Lee and Scott said. I couldn't recommend that enough. The observation is when we look at things like the bundle protocol. Ben, you asked what happens if this all works. What happens if we get the value that we expect to get out of things like BPv7, BPsec, and so on. As we have engaged with people who have different and challenged networking needs, they've gotten really excited because we have some new tools in town, and they can solve a lot of different problems. And some of those problems are heavy delay, and some of them are heavy disruption, and some of them are terrestrial, and some of them are near Earth, and obviously some are in deep space. And there's a lot of interest in trying to understand how we solve existing problems associated with that. And there's a lot of good there, and we're going to talk a lot about it through some of the presentations, later today and so on. But the aspiration here, and what I think is interesting, is that if we focus this on a discussion around the IPNSIG, is that special interest around interplanetary networking, and the hope that we come back and don't take our eye off the focus on very extreme scaled delays and very extremely scaled disruptions. And I think that there is there tends to be a tension between keeping that end state vision of what this all has to be able to do eventually, and what are those initial incremental steps along the way. Clearly, we need commercial, and clearly we need vendors that can help us build and get those initial capabilities. But also we need to be able to educate those vendors and those missions into what that end state is, and to not make approximations that box us into corners. And so one of the things that I think would be useful and hopeful, and I see it coming, and it's very exciting from the IPNSIG, is the holder of that vision of what real interplanetary networking means. And there are going to be a lot of usages and a lot of deployments of bundle protocol that are for other problems other than interplanetary networking, and that's good. But to me, it seems like IPNSIG is a good place to hold that overall end state architecture and vision. And I hope that the purity of that vision stays, so that we can always measure ourselves against it.
Hear, hear. Thank you very much, Ed. Well put. Okay, I see Oscar's hand is back up. Oh, Scott and Ed's hands are up. Are those legacy? And then Oscar's hand is up now again. So Scott, is that a legacy hand, or is that a new hand?
That is legacy. I haven't turned it off yet. Let me see.
Okay, so Oscar, you're on.
Can you hear me?
Yeah.
Yes.
Okay.
I think that Ed brought a topic that is very, very important. At this point, we are working with the resources that we have of where we can do this, that is on Earth, with small resources as well. But one thing that I like to bring up here with what it said is we would love to test these technologies with CubeSats and other spacecraft from the IPNSIG. So as we are in a call from NASA, I would like to explore the possibilities of having the opportunity in a basis to test these technologies on the real spacecraft. Because as Ed said, well, that's what is intended for.
I think all of us would agree that real space is more fun than virtual space, although I get the impression there are some people who think virtual space is going to be even more fun than that, but I'm not there yet. Okay, are there any other questions? David Israel's hands up.
Yeah, I just wanted to respond to that last one, and I know there's already been some communications about us doing some experiments over the LCRD, the LaserCom relay demonstration. Which has launched. We just as of last week, the payload is turned on, and we have done the first basic relay has happened, but we're still doing checkout. So the experiment period won't begin for real until the March time frame. So my intention is to. So it's 2 years on orbit to do experiments, and my intention is not just to be doing optical communications experiments, but to really be using this as a platform for us to do networking experiments as well. So we'll be looking for. There is the guest experimenter program, as you all saw, and you've already been in contact, but there's more to come to I'm trying to piece together some sort of challenge to go out there for people to demonstrate develop applications or certain things, and though we don't really have funding for people to do things, but we'll provide time on the links, and they'll get to have their application demonstrated across the NASA laser system.
Thank you. We can wait up to March, for sure. Fantastic. Thank you.
What David just said makes me imagine that at some point it might be amazing if there could be some space-based assets that are essentially dedicated to operating as a relay in a bundle-based network, and on a more or less permanent basis, so that whenever somebody wants to do a space-based test through a relay in orbit, that it will be there and available and could be scheduled. So something to think about, the possibility of having something dedicated for this kind of work, which is not quite, the LCRD work is very much focused, as David pointed out, on the laser comms, but his aspiration to expand it is extremely attractive. I don't know whether it could turn out to be a kind of permanent asset, but at some point it'd be wonderful to have something that belongs to the solar system internet, so to speak, that people can assume is there and incorporate into into its contact graph.
Everybody reached out to there's the amateur radio crowd that to get they do experiments and things that end up sometimes having space-based pieces to it. So getting that crowd and the CubeSats and university types interested and involved, that might be the quickest path to get something up there to do that.
That would be really cool. Josh, I see your hand is up.
To kind of add on to David Israel's mention of the LCRD stuff, currently as part of the ISS operations, we do have access to the Trek demo payloads, and through them, with discussions and some agreements and so on and so forth, we do have a certain amount of capability to provide the ability to demonstrate capabilities that aren't necessarily standardized yet, if that makes any sense. That might not be quite the right wording, but do some of these tests that we might be thinking about.
That would be great, and I can tell you we're all certainly prepared for unusual agreements necessary in order to get access to those assets, so thank you for that. Okay, I don't see any more hands up. So maybe we can wrap up and give back some time to the team, unless there are other questions or comments that others want to make. So I'm not sure who is still going to run the rest of this meeting. So I'm not sure who to turn it back over to. Is that Philip?
Yeah, I think Wendy's going to take over from here. And I think we're going to go over to the next session. We'll do CCSDS. And after that, we'll thank the guests for joining. But we'll go over to the Keith Scott's going to present on CCSDS. And then we'll also hand it to Wendy to MC the rest of the day. Great session, and I think there's a lot of collaboration opportunities here, and we'll be reaching out. And I have a near-term ask to tag up with the IPNSIG during a technical forum we're going to have maybe late spring, and I'll present that information to a larger Artemis community, and we can talk about collaboration opportunities. We also have somebody from our CIS office at Goddard, which is called the Communication, Innovation, and Synergies Office. I think I got that right. And so she sets up industry engagement sessions, and she works, Ali Hale, sets up engagement sessions with different industry folks and partners, and we'll work that out too as well, how we can figure out how to have collaboration in the future. So great opportunities we can have there.